So what we're going to look at now is finding extrema points on a graph of a function, and extremum are points, are points at which a graph changes from increasing to decreasing or vice versa. So for example, if I have a function that's increasing and then it changes from increasing to decreasing, or from decreasing to increasing, those points at which it changes are those are our extrema points. And so you can see, we've already done things like this. We're just talking about mins and maxes. On this particular curve, we went from increasing to decreasing, and then at this point we went from decreasing to increasing. So extrema is simply the plural of extremum, and this includes relative maxima and minima. So it's just relative because if we have a cubic function like this, the function is continuing on up, so it doesn't have an absolute maximum, but here in the close vicinity of the points on this curve, this is the highest point. And the same thing on this particular one, because it's a cubic function. We don't have an absolute minimum, but we have a relative one there. Okay, so where we find extrema on a graph where x is equal to c is when either the first derivative, and you plug in the c into that first derivative and you get a 0, or when you plug the c into the first derivative and it's undefined at that point. So remember, these are referred to as critical values or critical numbers. And where we have where the derivative is equal to 0, so this x value would be c here, and so at that point, if we'd find the derivative of the function, we'd plug c into it. We're saying, well, what is the slope of the tangent at that point? And it would be 0, because the slope of the tangent is horizontal there. So we can have extrema when the first derivative is equal to 0, or when it is undefined. So let's say maybe we have a curve that's looking something like this. So at this value, so when x is c here, we plug the c in to the first derivative, and it is undefined. Okay. Now let's talk about the first derivative test. So when you're looking to find the relative extrema of a function, you need to look just at the critical numbers of the function. So remember, the critical numbers then, when we find the first derivative and it's equal to 0 or it's undefined. Well, let's take a look at the first one. It says on the interval a to b, if the first derivative is negative to the left of c and positive to the right of c. So for example, let's say this right here is our c. So when we do the first derivative and we plug in values and we get a negative number, so it says when it's negative to the left of c, so here's c, and negative meaning we have negative slopes of tangent lines here. So the first derivative is negative, and then to the right, where the first derivative is positive, then we know that at that point we have a relative minimum because it's going from decreasing to increasing. The second one on the interval, if we have C is right here, we do our first derivative, and anywhere over in this region, if we plug in an x value in that region, we are going to get a positive number. So on the interval, when the derivative is positive to the left of an extrema, and it's negative to the right, which is what's going on over here because it's decreasing, then we have a relative maximum. Or if it's just a parabola, it's going to be an absolute maximum. If the sign doesn't change on either side, so we could have a function that looks like this, and we get a critical value here, and so this would be our C. So it's increasing over on the left side of it, and it's still increasing on the right side of it. So at C then, C is neither a maximum or a minimum. Let's take a look at this cubic function here. And so our goal is to figure out when we have mins and maxes here. So our first derivative test said that we should find the first derivative. So I get 6x squared and we want to set that equal to 0 to find our critical numbers. It's not it's always defined, so it's not undefined anywhere. So we're just looking at what makes it equal to 0. Let's factor out a 6. And then we'll factor it down to this. So we see we have critical values at 3 and at -2. So we take those critical numbers in, and then that gives us intervals. So the -2 is going to be to the left, so our first interval is going to be from -infinity to -2. And then we'll have an interval from -2 to 3 to our next critical value. And then we'll have from 3 that critical value on up to positive infinity. So now we're going to do a test point in each one of those intervals. So from -infinity to -2, let's try -3. I want to find the sign of the derivative then. So I'm going to plug that into the derivative. So here's my derivative, but I'm going to plug it into this one because it's a little bit easier to calculate when you have the factors. So we'll get the 6 is always going to be positive. I plug a -3 into the first factor, we get a negative, and into the second one I get another negative. So when we multiply it out, we get a positive. So if the derivative is positive, that means it's increasing on that interval. Let's take a test value of 0, plug 0 in, we get a positive for the 6, a negative when we plug it into that next factor, and a positive, so that's going to give me a negative. So that means the function is decreasing on the interval from -2 to 3. And then let's take 4 here, plug in a 4, they're all positives. So the sign in that interval is going to be positive, so that means the function is increasing on that interval. So if we go from increasing to decreasing, that means at -2, went from increasing to decreasing, so we have a maximum at that point. So if it asks for what is the maximum point, then you actually have to plug that -2 into the original equation, because we want to find a point on that function. And if you do that, you'll see that the y value is 58. So our maximum is 58, and it occurs at the point -2. And then if I look here, we went from decreasing to increasing. So that means at 3, we have a minimum. And if it asks what is the minimum value, then you take the 3, you plug it into the original function once again. You should get a -67 when you do that. So we have a minimum, a relative minimum at -67 when x is 3. Okay, here's our next function that we want to look at. Let's find when it's increasing and decreasing again. So we're going to do the first derivative. So we get 4x cubed minus 3x squared. Our critical values, well, it's never undefined, so we're just looking at when it's equal to 0. So we're going to take out our greatest common factor. Set it equal to 0. See that we have critical values at 0 and at 3/4. So that means then our intervals are going to be from -infinity to 0, 0 to 3/4, and 3/4 to positive infinity. Let's take a test value in each of those regions. So I'm going to take a -1 here. We want to find what the sign is, so we plug that into the derivative function. If we plug it into the original function, we just get a point. So if we plug it into the derivative, it'll tell us where it's increasing or decreasing. So if I plug it into the derivative, a -1 cubed is a -1. So, well, oh, actually, let's plug it into this one. So -1 squared is a positive. 4 times a -1 minus 3 is a negative. So we get negative on that interval. So when it's negative, that means the function is decreasing on that interval. Between 0 and 3/4, let's try 1/2. Okay, 1/2 squared is a positive. 4 times a half is 2. 2 minus 3, that's a negative. So we're going to get a negative there. So that means it's decreasing here. And then from 3/4 to infinity, let's try 1. If you plug in a 1, it looks like we're going to get a positive. So it's increasing on that interval. Okay, so we're just looking for relative extrema. So because it goes from decreasing to decreasing here, 0 is not an extrema, but 3/4 is. So, and then let's look, we go from decreasing to increasing. So it's decreasing to increasing. So that means at 3/4 we have a minimum. We have a minimum at 3/4, and that minimum value is, to figure it out, you have to plug it into the original function. And if you'd plug it in, you'll get a -27, over 256, I believe. Okay? So it didn't change directions there from decreasing to decreasing, so it's not an extremum. Okay, and here's our last one that we're going to do together. So we do our derivative again. So we get 2 minus 2x to the -1/3. Okay, let's make that into a fraction then. So we've got 2 minus 2 over x to the 1/3. So to figure out where we have zeros and stuff, we want to make that a single fraction. So our common denominator is going to be x to the 1/3. So we've got 2x to the 1/3 minus 2 all over x to the 1/3. With that then, let's factor the 2 out of the numerator. Okay, so it's undefined at 0, so a critical point is going to be 0. And then if I look at the numerator, what makes the numerator equal to 0? Well, let's set it equal to 0. Solve it, so we're going to add that one over. And then to get rid of a cube root, the opposite of raising it to the 1/3 or taking the cube root is to cube both sides. So we get 1. So our other critical point is at 1. Okay, so that gives us 2 critical points. So we have 3 test intervals. Negative infinity to 0, 0 to 1, and 1 to infinity. Let's take a test value of negative 1. If we plug it into the, let's plug it into this guy right here. So remember, into our derivative. So the cube root of a negative 1 is negative 1. So subtract 1, you get negative 2. Multiply it by 2, you get a negative. In the denominator, you get another negative. So a negative divided by a negative is positive. So it's increasing on that interval. Between 0 and 1, well, we got to do a cube root of it. We can pick anything, you know, see if it's positive or negative. I'm going to take 1/8, since we can take the cube root of that. So the cube root of 1/8 is a half. A half minus 1 is a negative half. So it looks like our numerator is going to be a negative number. In the denominator, the cube root of 1/8 is 1/2. So that's going to be a positive. So negative divided by a positive is negative. So it's decreasing from 0 to 1. Here, let's take an 8, since we can take the cube root of that. The cube root of 8 is 2. 2 minus 1 is a positive. So it looks like our numerator is going to be positive and our denominator is going to be positive. So it's increasing on that interval. So it changes from increasing to decreasing. And then it goes from decreasing to increasing. So it looks like 0 here is going to be a maximum. So we have a maximum at 0 something. Okay, so if we plug the 0 in, plug it into the original function, and we get a 0. And so we have a maximum at 0, 0. And then it goes from decreasing to increasing, so that means it's a min, and the min occurs at 1. And to figure out what the y value is, or what the y value is, yeah, you plug the 1 into the original function. Looks like we get 2 minus 3. So at negative 1. Alright, so that was the last one that I'm going to do with you. So now what I'd like you to do is I got 3 problems that kind of mimic the ones that I just did. So I want you to try your hand at those. We can talk about what you came up with when you return to class then. So good luck with those.